Hello, everyone. I'm Professor Bojović, and I will present this paper on behalf of my colleagues, PhD Petrov, Master of Science Trajković, PhD Milošević at Innovation Center, and PhD Golubović, Professor of Sedmak, and Professor Mišković at Faculty of Mechanical Engineering. Since additive manufacturing, also known as 3D printing, is evolving significantly, has become necessary to study the properties of the different materials used for these processes. We select one of 7 additive manufacturing technologies, and that is that polymerization. We selected SLA industrial printer and DLP desktop printer to produce standardized specimens for mechanical examination. So we talk about photopolymers, and we all know that right now it's a very intensive investigation about different mixtures and different types of resin material in order to achieve desired mechanical properties of printed parts. So we choose ABS material, and for resin, we choose ABS-like resin material because it has not been sufficiently studied. And the aim of this research was to determine the mechanical properties and also differences in behavior for the same material, ABS-like resin, printed with 2 kind technologies, SLA and DLP. As producer claimed, ABS resin improves the printing efficiency due to short curing time and low viscosity and good fluidity. And also, printed parts have moderate detailed performance, good appearance, high strength, and satisfactory functionality. So we prepare geometry of our samples according to standard ISO 527 for tensile testing specimens, because we decided to testing mechanical properties, and we will publish a paper according to result of pressing and 3-point bending, but right now we will present only the results considered to tensile testing. Our specimen was built in a rotation 45, 100% was infill density, and we printed in the same condition for both 3D printing technologies, according to a set of parameters which is different for each of that technology. We conduct mechanical testing, tensile testing at Universal Testing Machine Shimatsu with loading cell of 100 km capacity and loading rate of 1 millimeters per minute. And we monitored mechanical properties such as elastic modulus, maximal force, ultimate tensile strength, maximal displacement, maximal strain, yield stress, and toughness. We have 5 specimens in one batch printed on SLA printer and DLP printer, and you can see the left side, it's a specimen made by SLA, and right side, you can see the printed specimens at DLP printer. They have a different appearance, and geometry is much better here for SLA printed parts. But for DLP printed parts, you can see some kind of crooked edges right here, so not so good. And also, it's a different according to touch effect. This SLA printed parts is very tough and look like typical plastic parts made by, let's say, injection molding machine. But this one, DLP printed parts are quite different. They have such a silicon touch effect, and it's not so strong and tough as the previous one. A further analysis was conducted with 2D microscopy, and you can see the different topography and morphology of examined specimens, and also you can see the similarities between them. Because white polymerization made very dense and isotropic parts, you can see that both those fracture surfaces are very dense and isotropic. But here you can see the difference. This is initial start with low strength, and you can see this shear part of outer layers start from here, then involved to this bristle part and ended with ductile part. For DLP printer, initial was like striation here, and then involved to brittle part and finish it. So results was in the semester Shopster give us like this table with the different parameters of mechanical properties, and we additionally processing in MATLAB software, so we can make this stress strain curves, and in comparison of both of them, you can see the difference. Although it's the same material, ABS like resin, but it's a different technology that we made those parts. So the mechanical properties are very dependable to this kind of technology. It's not the same. You can see the curve, and this batch of 5 specimens has very good repeatability here, and not so representative repeatability here for the LB batch. In more details, we can compare elastic modulus for both of that. This is average curve for SLA and average curve for DLP specimens. So elastic modulus are quite different because there is no lines here. It's about 2,500 for SLA and almost 900 for DLP specimens. And there is a difference in the maximal stress around 57 megapascal for SLA and around 26 megapascal for DLP. Additionally, if we compare max strain and elongation to break, you can see the difference. So there is a quite different value for SLA and a very similar value for these 2 parameters for DLP. So we can say it's more durable material if we printed specimens using DLP technique. According to energy, this area beneath the curve, we call it energy the material can absorb during the tensile testing. And according to this value, SLA builded part can absorb more energy. In conclusion, generally, we can say that the same material, ABS-like, when we use it in a different additive manufacturing technology, you can see that different appearance and different mechanical properties. According to elastic modulus, it's a quite higher for SLA-made specimens, and according to maximal stress, also higher according regarding to SLA material. And energy is more so can absorb more energy if we made specimens on SLA machine. But for the DLP made specimens, they can strain more and elongation to break is higher. So as a conclusion, SLA specimen could undergo high stress and DLP specimen could persist longer and elongate more. According to requirements of our customer, we can offer one or another of these 2 technology for preparing the completely new part with these printing technologies. At the end, this is only results for tensile strength. We prepare for paper results according to bending and compression. So thank you for your attention.